In this video clip, I'm going to walk you through again how to use a interactive decision tree tool by which you can grow your own tree one node at a time. So let us go back to the Citrix platform we had, and in order to beautify what's shown on my diagram, I'm going to rearrange them. So by right-clicking it, select layout and select horizontally, and now it looks tidy. So with this, I'm going to bring in a decision tree node. It is under Model tab, Decision Tree. Second from the left, select and drag. And I'm going to connect Data Partition node to this Decision Tree node. Okay. And I'm going to select Interactive mode from this Properties window. So under Train Header, the second from the top, Interactive, select this box, and it will open up a new window. Interactive Decision Tree window will appear. All right, so this is the root of the tree. So from here, we're gonna do a recursive partitioning of the training set in order to isolate concentrations of cases with identical target variable. Let's say donors from non-donors, non-donors from donors. So let us right-click this root node and select split node. And this chart basically shows you the information gain, the amount of information gain with respect to each variable. Suppose it is selected. So gift count 36. It will give you the maximum amount of information gain. The information gain, by the way, is shown on the third column. They are already sorted and displayed in descending manner. So all you need to do is select the one at the top. That gives the maximal information gain. So I'm going to select this one. As soon as you hit OK button, now you have a tree with this 2 branches. So gift count 36. Whenever it is less than 2.5, we have this. Greater or equal to 2.5, you have this. On the left hand side, by looking at the proportion of ones, either on the train and validation set, 42, 43, they are below 50%. Originally, everything was 50%. It's 50% 0, 50% 1. But now, by partitioning this way, now you have a purer subset, children sets in other words. We're able to isolate a higher proportion of zeros on the left, higher proportion of ones on the right hand side. So you can certainly continue this partitioning process. Right click here and select split node, and the median home value appears to be the highest information gainer, and select that one. And you see that on the left, the grandchild node, branch, now it has even more concentrated zeros and ones, fewer percentage of ones and higher percentage of zeros. Similarly, you can expand this one by selecting split node, select the one with the highest information gain, hit OK button. So now we have a tree with 4 branches, 4 segments. And seeing this split value of $67,350 was selected as the split value for median home value. But as we discussed in class, we want this to be more socially acceptable. So we're gonna round up this value to 70,000. So to do that, we have to go back to the earlier root. The upper above node, and reselect split node, and select edit rule, and enter new split point, which is 70,000, and select add branch, and get rid of the earlier split point 67,350. So I'm gonna remove this branch and keep this below 70,000, above or equal to 70,000. These are our new split points, and select OK. And OK one more time. This way, you can, although you are deviating from the optimal split points, but this one is arguably more socially acceptable, at least in terms of its split point with respect to median home value. All right, you can certainly continue this partitioning process, but there's a way to sort of automate this entire process. So I'm gonna click the root node at the top and right click and select train node. This way you can see the tree has already grown to the maximal level. So I'm gonna hit view and fit to page, or not here actually, sorry. Anywhere within this tree view window, right click and hit view and fit to page option. And now this is the maximal tree, so to speak. And I think we have 15 terminal leaves. 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 10, 11, 12, 13, and 14. Do we have 14 or 15? Let me count it one more time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Yes, this is a tree with 15 terminal leaves or end leaves, end branches. So I'm going to close this one. And all right, let me just. So I should have not clicked exit button. So within here, not here. Click view and select subtree assessment plot. This one basically displays the relationship between the how accurate the model is, or some other times, as you see here, the misclassification rates, how bad the model would be as we increase the extent of model complexity, which is measured by number of leaves there are in the tree. So as we allow for more terminal leaves, terminal end nodes, the model becomes more complex, and this is what happens on misclassification rates of the model when they are evaluated against training data set on the blue plot and the validation set on the displayed on the red plot. So obviously, as the model gets more complex, the error rates, it continue to get better, indicating the fact that the model is forced to overfit the data we have, the training set. When in fact, when it's assessed on the validation set, as the model gets complex up to the point of 7 or 8 or even 9, you can reduce misclassification rates, but past that point, the misclassification rates climb up, it gets worse. So presumably you can say, well, we should allow for, say, a tree with the 7 leaves or 8 leaves. That's the best one, which can be the generalized and unseen data points such as validation set. And in the next tutorial session, the video clip will show you how to optimize the complexity of decision trees.